All right, good morning, guys. So today we are going to do section 4.2, page 258, problem number 45, in which they are asking you to check if 2 is a 0 of your polynomial p of x equal x squared plus 2x minus 8. So there's several ways to tackle this problem. First of all, if x equal 2 is a 0, that means you will end up to have the parenthesis x minus 2 equal 0. And basically what we're trying to do is, if we have the polynomial degree 2, we are expecting to have two parentheses. Each parenthesis will give us a 0 using the zero product property. And this zero product property, I would like to remind you that right here, that if you have a times b equals 0, that means a equals 0 or b equals 0. So in that case, when they are telling us to check if x equal 2 is a 0, that means our parenthesis is going to be x minus 2, and so therefore, using the zero product property, that means x minus 2 equals 0. So obviously, if I want to find the other parenthesis right here, okay, what I had to do was to basically divide my polynomial p of x by x minus 2. And for that, I did use my synthetic division. I took what I saw, which is minus 2. And so I took negative 2 and the coefficient 1, 2, and negative 8 in decreasing exponent. As you can see, there is a decreasing exponent, 2, 1, and then no more. So I bring down the 1. Negative 2 times 1 equal negative 2. I always subtract because I took what I saw. 2 minus 2 by minus give me a plus. 2 plus 2, because now that's become a plus. 2 plus 2 equals 4. Negative 2 by 4, negative 8. Minus 8, now that becomes a plus. Plus 8 equals 0. And that justifies the fact that x equal 2 is a 0 because my parenthesis x minus 2, when I divide, I have no remainder. I could have also used another technique, which is using directly the value of my supposedly 0, which is x equal 2, using my synthetic division, but this time I will add. And I'm doing the same thing, 1 bringing down the first term, 2 times 1 equals 2, then 2 plus 2 equals 4, 2 times 4 equals 8, negative 8 plus 8 equals 0, and again, that shows me that there is no remainder, so x equals 2 is a 0. I could have also, and I think it's even quicker, is just substitute the value of x by 2 inside my polynomial, and if p of x equals 0, that means 2 will be a 0 of my polynomial, and I can clearly see that when I substitute x by 2, p of 2 equals 0, so 2 is a 0 of my polynomial. I can do exactly the same thing for the problem number 47. And as you can see, if I want to divide my polynomial, it's going to be long. I'm going to show you that in a second. But the best way is to supposedly substitute x by 4. And when I substitute x by 4, I can clearly see that it's not equal to 0. So I can say right away that x equals 4 is not a 0 of my polynomial. But let's imagine that x equals 4 is a 0. That would mean that the parenthesis x minus 4 equals 0. And so again, I can definitely try to substitute, do the synthetic division, and hopefully, if x equals 4, I'm supposed to find a 0 as a remainder. As you can see in the problem that I just did, rather I use negative 4 coming from the parentheses or directly x equals 4 as the supposedly 0. Rather, if I subtract in this case or add in this case, I don't have a 0 as a remainder. That proves us that what we said when we substitute x equals 4 inside our polynomial was different than 0. That proved us that x equals 4 is not a 0 of the polynomial. And as you can see in this problem number 54 now, when you have to deal with x equals square root of 7, doing the synthetic division by using directly the value of your 0 and therefore you are going to add, it's going to be long and very complicated. Instead, I think that if you substitute x by square root of 7 and you calculate p of x, you are end up to have equals 0 at the end. And so that shows you that x equals square root of 7 is a 0 of your polynomial. Now, I wanted to show you this problem number 81 and 86 to show you that we are still able to do the same kind of division, but unfortunately for us, for number 81, we cannot do a synthetic division because we are dealing with something much more complicated than x minus k, because this time we have 3x minus 7. So therefore, what we're going to do is just a synthetic long division, and in the long division I take my first term, 3x to the fourth, and I divide by the first term of my denominator, which is 3x, and that gives me x cubed. That gives me x cubed. Then x cubed will be distributed to 3x minus 7, which gives me 3x to the fourth minus 7x cubed. Because I do a long division, I subtract, and I end up to have 0x cubed. I need to bring down the 0x square. I will have to bring down the 6x and the minus 16 almost instantaneously. And I end up to do the same thing. I take my 6x, I divide by 3x, that gives me 2. I distribute 2 to the 3x minus 7, that gives me 3x, 6x minus 14. I subtract, because I always subtract when I do a long division, and I end up to have negative 2. There is a reminder, and that tells me that obviously 3x minus 7 cannot help me to find the 0 of my polynomial, first of all. Second of all, that tells me that the division of 3x to the fourth minus 7x cubed plus 6x minus 16 divided by 3x minus 7 equal x cubed plus 2 plus negative 2 over 3x minus 7. I would like to remind you that is basically what we are doing is a p of x divided by x minus k, whether you have a coefficient right here or not, will be equal to a coefficient, to a polynomial, so I'm going to call that another polynomial, plus the remainder divided by x minus k, which is why here I just put plus, because plus. Now, if you want at the end transform plus and the minus right here by minus, you can also, obviously. Last problem, problem number 86. Same idea, 3x to the fourth minus 2x squared minus 5 divided by 3x squared minus 5. Remember that you need to have a decreasing exponent. This is why you have 3x squared plus 0x. And same thing for 3x to the fourth plus 0x cubed minus 2x squared plus 0x minus 5. And I do exactly the same thing, which is I take the first term, 3x to the fourth, and I divide by 3x squared. That gives me x squared. I distribute x squared to 3x squared plus 0x minus 5. I end up to have 3x squared right here. I bring down the 0x and I bring down the negative 5. I divide 3x squared, the first term divided by the first term of my denominator. This is the first term of my denominator. I end up to have 1. So I report the 1 plus 1 right here. I distribute this plus 1. And I end up to have 0. That tells me right away that 3x squared, let me write that in a better way. That tells me that 3x squared minus 5, I'm just going to not consider the 0x anymore, will help you to find the 0 of p of x. And so if I have to write the answer for the division, it will be x squared plus 1. All right, guys, I hope you have been able to follow. Don't forget, you can always pause and rewind and listen to me again. I love it. I know you like to hear my French accent. So have fun, and I will do another video for you.